So hello guys, let's start our second lecture of Laplace Transform. So yesterday we talked about the second shifting. We talked about the second shifting theorem. We talked about the second shifting theorem. What the second shifting theorem states that if Laplace of f of t minus a of h of t minus a is equal to e to the power minus s fs, where where f of s on Laplace in f of s on Laplace of f of t and nothing more than that. And what is h of t minus a? It is a unit step function 1 when t greater equal to a and 0 when t less than a. We yesterday in the previous lecture I told you about its proof and its inverse proof and all. So today we will start do some questions, right? Today we will do some questions right now. So questions will be Laplace transform of a function of ft, which looks like where ft is like sine t minus pi by 3 when t greater equal to pi by 3 and 0 when t less than pi by 3. So if this is the function and its Laplace we have to do. So how we will do it? So it looks like unit step function, but how? If we take sine t minus 3 common out of this piecewise defined function, so we will get 1 when t greater equal to pi by 3 and also 0 when t less than pi by 3. So here this part looks like h of t minus a, where a is the pi by 3, right? If you see here, if we put a is equal to pi by 3 here, it exactly looks like it. So this part is sine of t minus pi by 3 dot h of t minus pi by 3. I'm sorry for my bad handwriting, but I know you understand it because I'm telling when I'm writing that. So we have to take Laplace of this. So Laplace of f of t minus a dot h of t minus a is equal to e power minus as is equal to e power, here a is equal to pi by 3, so it will be minus pi by 3 dot s, and fs is equal to Laplace of ft. Here ft is sin t and Laplace of sin t is equal to, we know that it is 1 by s² plus 1, because we did about our first lecture that Laplace of sin at is equal to a by s² plus s². If we put a is equal to 1, then this comes. This is pretty easy. And now we're putting this into here. So 1 by s² plus 1. So this is the Laplace transform with this. This is a very easy one. Now we will do another one problem. This is problem number 1. Problem number 2, where ft is kind of e power t minus a when t greater than a and 0 when t less than a. So how would you do it? So it is pretty easy. Again, it is pretty easy. If we take e power t minus a common out of this, then 1 when t greater equal to a and 0 when t less than a. Again, it looks like our h of t minus is the unit step function. So e power t minus a dot h of t minus a. So it looks like the Laplace of f of t minus a and f of t minus a and h of t minus a, the unit step function. And if we take its Laplace, what we get? E power minus as and fs, where fs is the Laplace of ft. Here ft is e power t and Laplace of e power t, and Laplace of e power t is 1 by s minus 1. If we see Laplace of e power t 1 by s minus 1, we would say how Laplace of e power a t. In the first lecture, we taught the formula that Laplace of e power a t is equal to 1 by s minus a. So if we put a is equal to 1, then it will be 1 by s minus 1. So that's also a pretty easy one. Also a pretty easy one. Now we are doing into some another problem. Like it is all the also very easy, so don't like here ft is like cos of t minus 2 pi by 3 when t greater equal to 2 pi by 3 and 0 when t less than 2 pi by 3. So how to do it now? again, if we see closely and if you listen to my words carefully and you see the previous lecture, then you would simply know that if we take cos t minus 2 pi by 3 common out of this piecewise defined function, then what will be there? Like if I take common cos t minus 2 pi by 3 and taking common, so from the piecewise defined function, so here it will be 1 when t greater equal to 2 pi by 3 and 0 when t less than 2 pi by 3. Again we are seeing that it is cos of t minus 2 pi by 3 dot h of t minus 2 pi by 3. Okay, and now we have to take a Laplace of it. Here we can easily see that here a is what? Please say in the comments. I think my camera is not working well. Now it's working well. If you see that it is the camera's focus problem. I don't have a such good phone. Here a is equal to 2 pi by 3. Here a is equal to 2 pi by 3. So Laplace of cos of t minus 2 pi by 3 dot h of t minus 2 pi by 3 is equal to, as here a is equal to 2 pi by 3. So here it will be 2 pi by 3 dot s and fs, where fs is Laplace of cos t. Laplace of cos t is not s by s square plus 1. You will set how, if in the first lecture we told about that Laplace of cos at is equal to s by x square plus s square. So if we put a is equal to 1, then it is easily can be determined s by s square plus 1. Very easy one. So now we have for the forward Laplace transform, like all the Laplace transform one, but we can call it as a forward Laplace transform. Same words, just different languages. We have done it. So now we have to do some like inverse Laplace transform. That's where the things gets tricky. A little bit tricky, not so much. So what about the second shifting theorem? I told it in the previous lecture. Let Laplace inverse of f of s suman ft. Then Laplace inverse then Laplace inverse of e power minus as dot fs, it will be how much? You say f of t minus a dot h of t minus a, where h of t minus a is a unit step function and it is 1 when t greater equal to a and 0 when t less than a. You know it. I have tell a lot of times here, and here also it is written here h of t minus a. So now get into some problem. So question number 1, Laplace inverse of e power minus pi by 3 dot s dot 1 by s square plus 1. So what do you first think? So now here e power minus as, we have our standard formula. So here a is equal to pi by 3, where here a is equal to pi by 3, and Laplace, and this part this part is fs. This is e power minus as part and this is fs part. If we see this fs, Laplace inverse of fs, here Laplace inverse of 1 by s square plus 1, we know it's sin t and a is equal to pi by 3. So you can directly write it as sin of t minus a and sin and h of t minus a. Like that, I am explaining it again. Here this is the Laplace inverse of e power minus pi by 3 dot s by dot 1 by s square plus 1. So this is e power minus as part and this is fs part. According comparing it to the e power minus as part, this term we got a is equal to pi by 3 and this is fs part. Laplace inverse of this part is equal to sin t. So if we put in the formula, it's sin t. So it is sin of t minus a and h of t minus a, and a is equal to pi by 3. So if you listen to my words carefully, then it will be sin of t minus pi by 3 dot h of t minus pi by 3. Or you can write it like another way, like this is some JK key problem, but we will do it here. When t greater than pi by 3 and 0 when t less than pi by 3. So is the camera visible? It's camera's focus problem. So now okay, so I am reviewing the footage now because my camera is not working well. So थोड़ी देर बात करूँगा, इस और कुछ क्वेश्चंस बाकी हैं. So our Next question is another tricky one. Start. Second number, Laplace inverse of 1 by s square dot e power minus 2s. So this is e power minus s part and this is fs part. So clearly a is equal to, we're comparing a is equal to, and this is Laplace inverse of s 1 by s square. What was it? Laplace s square 1 s square. What was it? If we remember Laplace inverse of s power n plus 1, s power n plus 1, it was n factorial by t power n plus 1 by tau of n plus 1 by gamma of n plus 1 by s power n plus 1. So in putting that formula, we can easily get it t. If you don't understand it, please go to the previous lecture and see. Here it is thoroughly told. So this is a is equal to, and fs and this fs is equal to t, and this Laplace inverse of this 1 square through t. So now it will, so our ft is equal to t. So it will be like f of t minus a, h of t minus a. Here a is equal to ft is equal to t. So t minus 2 or h of t minus 2. So it will look like t minus 2 when t greater than 2 and 0 when t less than 2. It's a pretty easy one. So now here all are pretty easy ones, not some big deals. Like Laplace inverse of s by s square minus omega square dot e power minus s. So here clearly comparing this with e power minus s, a is equal to a, the same one, and s by square plus square. This is the fs part. So what is inverse part? Laplace inverse of s by square minus s square. If you see it, it is the cos hyperbolic function formula. Cos Laplace inverse of s by s square minus s square is equal to cos hyperbolic at. So in that formula, if we put a is equal to omega, it will be cos hyperbolic omega t. It's pretty easy one. So again it is so ft is equal to this one. This is f of t minus what, h of t minus a. Cos the answer will be cos hyperbolic omega t minus a dot h of t minus a. If we do cos hyperbolic omega t minus a when t greater equal than a, or 0 when t less than a, done. And another some things, then we will go to the next formula, and I have to review my footage also. Laplace of we are doing it, using it, but I am saying the formula for your sake. Laplace of c1 not f1 t or c2 not f2 t. I am not telling, I am telling the abbreviations. Here c1 is a constant, f1 of t is a function, c2 is another constant, f2 is another function. So the answer it's here would be c1 dot Laplace of f1 t plus c2 dot Laplace of f2t, and that's another one. So what's this one? So I have told you two kind of. So what do you think? If there is a Laplace of some piecewise defined function, then how you could do it? So like I am giving the heading piecewise defined function. It's a pretty easy one. So let an example, f of t is equal to t when 0 less equal to half, t belongs to 0 to half, close, and t minus 1 when t belongs to half to 1, and 0 when t greater than 1. So okay, my camera is making some problem. So it's okay now. So how to Laplace of itself? If you do the Laplace formula, what was Laplace? Laplace was 0 to infinity e power minus st dot ft dt, right? This one. So here it will put how Laplace of f of t. I have to break it in intervals. From the interval 0 to half, 0 to half, there it will put this value ft in the interval 0 to half. Value of t is equal to t, value of ft is equal to t dt, and from half to 1 interval, this is value is t minus 1. So insert e power minus st dot t minus 1 dt plus half to plus 1 to infinity in this interval. This is 0. So e power minus in this interval value of ft is equal to 0. So e power minus st dot 0 dt. So these terms gets 0, and we have to calculate that, and it's okay, right? So now I am telling you one of the most complicated concepts. If you understand it, then it is very good. So we talk about Laplace of sin t, Laplace of cos t, Laplace of e, Laplace of anything. So what if Laplace of sin t square? What if Laplace of cos t square? What if Laplace of sin root t? What if Laplace of cos root t? What if Laplace of e power minus root s? Then how? This is going to complex, but I will explain it. Laplace of sin root t. What does it mean? It means 0 to infinity e power minus st dot sin root t. This integral is a pretty tough one. We can't we do it, but it will be very longer and very tough problem to do. I will only tell the process because the process is necessary, not the answer. What if Laplace of e power minus root s? It is 0 to infinity e power minus st e power minus root s minus e minus root t e power minus root t dt. So it is another one tough one. How we could do that? If we seeing it well, 0 to infinity e power minus st plus root t dt. This is a pretty one tough integral. We can't do it. So for this, we know Taylor series expansion. Yeah, we know Taylor series expansion. So what we are talking Taylor series expansion. If we are taking about the formula, like if we use the formula e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial dot x to the power n by n factorial till dot. But is this formula right? No, this formula is not right. This formula is only right if we see Taylor series expansion. Formula is only right when we are taking about only x is equal to 0. What is Taylor series real formula is? Fx is equal to f of x naught del f by del s at x1 x naught dot x minus x naught plus 1 by 2 factorial x minus x naught whole square del 2f by del x2 at x is equal to s naught till dot. It is Taylor series expansion of a function fx at x is equal to x naught. At x is equal to x naught. So if we do this, if we know that e power x is equal to 1 plus x by 1 factorial x square by 2 factorial x square by 3 factorial till infinity, we use that formula, and in the place of e power minus x, e power minus root s, we will do this. But it will be right? No. Why? It is expansion is only valid when it is expanded about x is equal to 0. When it is expanded about x is equal to 0. Otherwise, this formula is not right. You can see, you can check my results with any AI. That this formula is only when the e power x is expanded about x is equal to 0, not for every time. Okay. So how could I do this? So if we see our Laplace of f of t. So f of t, this is if 0 to infinity e power minus st ft dt. What does e power minus st mean? What does e power minus s graph? This is like e power minus s graph, and here 0, this value 1, and till infinity it goes 0. So formula is this formula is not right, but we can use this. We can use the extension about x is equal to 0. But how? At x is equal to t is equal to 0, e power minus st's value is equal to 1, and as we grow t's power to 100, 200, 1 million, 2 billion, trillion, it goes to 0. So its value, this value, e power minus st's value would go from 1 to 0. This value is in the range of 0 to 1. So t's value is in the range of 0 to 1. So 1 to slowly going to 0, 0, 0, 0, as we are making the t's value upward and upward. So from 1 it goes to 0 to 0 to 0, as its value as the e power minus st's value is going to 0, going close to 0. So that's why we can expand it about t is equal about t is equal to 0. Only this I am telling it again. Listen carefully. This is e power minus x graph. At 0 it is 1, and when in infinity, at infinity it goes 0. And in this integral, the limit is from 0 to infinity. At 0 is equal to 1, and as we kept the power increasing of t, like t is equal to 1, t is equal to 2, 3, 4, 100, 200 to 200 million, 200 billion, it will go to 0, 0, 0, 0. As it is going to 0, that's why we can expand that ft at t is equal to 0. Listen my words carefully, and you will understand. So now if we have to do some complex Laplace of sine root t, it would be 0 to infinity e power minus st dot sine root t, as we can expand it about t is equal to 0. Why? As about when t and t going to infinity, this term goes 0. So that's the only reason we can expand it about t is equal to 0. So about what is sinus expansion about x is equal to 0? X minus x² by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial dot infinity. So what is sine of root t? Root t minus t power half minus t power 3 by 2 by 3 factorial plus t power 5 by 2 by 5 factorial minus t power 7 by 2 by 7 factorial dot till infinity. So now put this here. So now we are taking Laplace of this. Laplace of sine of root t is equal to Laplace of t power half. Laplace of t power half minus 1 by 3 factorial, constant बाहर आ गया. Laplace of t power 3 by 2 plus 1 by 5 factorial. Laplace of t power 5 by 2 minus 1 by 7 factorial. Laplace of t power 7 by 2 till infinity. So if we do the one step ahead and just don't and just ask to don't do, it's here it's here. I am only telling you the process, and it will the answer came with the gamma function manipulations. I would show it only. What is Laplace of t power half? Laplace of t power n is equal to gamma n plus 1. I told you that we will use this formula when n is equal to like fractions, s power n plus 1. So Laplace of t power half is equal to half plus Laplace of 3 by 2 by gamma of 3 by 2 by s power 3 by 2. So it is gamma of 3 by 2 by s power 3 by 2. We will put the formula at that's it. But now some another Laplace of e power root s. If you in any mathematical computation do this integration, it will be like amazing. E power minus st minus root s dt. It is a pretty tough integration, but how to do it? We will do it by Laplace. E power x expansion is 1 plus x by 1 factorial x square by 2 factorial dot infinity. So e power minus root s is equal to 1 minus s power half by 1 factorial plus s by 2 factorial plus s power 3 by 2 by 3 factorial dot till infinity. So Laplace of e power minus root s is equal to Laplace of 1 minus 1 factorial Laplace of Laplace of it is t Laplace of t power half plus 1 by 2 factorial Laplace of t Laplace of t is minus 1 minus 1 by 3 factorial Laplace of t power 3 by 2 dot till infinity. And you can do it if you are interested in math, then you can solve it, or otherwise this part is not so okay, this part is done now. So now we will talk about some another formulas that is in our syllabus, like Laplace the multiplication of t. If it is in our syllabus, if Laplace of ft is equal to f of s, then Laplace of t dot ft is equal to minus d by ds of fs, and Laplace of t power n dot ft, it is equal to like minus 1 whole power n d power n by ds power n of f of s, right? So how its proof came, if I where this proof came, and I will do first I'll do some questions. 1, Laplace of t sine 2t, Laplace of t sine 2t, Laplace third is Laplace of this formula, so we have to take the Laplace of sine t, Laplace of ft, Laplace of sine 2t is equal to 2 by s square plus 4. So it will be minus d by ds of fs, so it is minus d by ds of 2 by s square plus 4. So it is like minus s square plus 4 whole square, s square plus 4 into 0 minus 2 into 2s, so it will be 4s by s square plus 4 whole square. So then what about Laplace of t cos 3t? We know Laplace of cos 3t is equal to 3 by s square plus 9. So it will be minus d by ds of 3 by s square plus 9. Okay. So s square plus 9 whole square. S square plus 9 into 0 minus 3 dot 2s. It will be 6s by square plus 9 whole square. Understand? So I am explaining it's the formula again. Laplace of t sine 2t, Laplace of t ft is equal to minus d by ds of fs, where fs is the Laplace of t ft. So here when doing the Laplace of t sine 2t, so we have to do the Laplace of ft. We have to do Laplace of ft, no, Laplace of sine 2t. Laplace of sine 2t is equal to 2 by s square plus 4. So it will be minus d by ds of s square plus 4. Like we are in this formula, in place of fs, we are putting the 2 by s square plus s square, and then by chain rule, s square plus the 4 the whole square in the denominator, minus is here, s square plus 4 into differentiation of 2, it is 0, minus 2 into differentiation of s square plus 4, it is 2s. So this term goes 0, and minus plus, so 4s by s square plus 4 whole square. Okay, done. And Laplace of t dot cos 3t, Laplace of t dot cos 3t, so it is minus d by ds. So Laplace of cos 3t is equal to 3 by s square plus 9. So minus d by ds of 3 by s square plus 9 is equal to like minus here s square plus 9 the whole square, s square plus 9 in differentiation of 3, which is 0, and minus 3 dot 2s. So this is what is 0 and minus plus. So it is 6s by s square plus 9 the whole square. So it's done now. So now about the inverse formula. So now about the inverse formula. If Laplace inverse of fs is equal to ft, then Laplace inverse of f dash of s is equal to minus t ft, or minus t Laplace inverse of f of s, or Laplace inverse of f of n time differentiation of s is equal to minus 1 whole power n minus 2, no, 2 minus n dot Laplace inverse of f of s, or Laplace inverse of dn by dsn of fs is the same one, is equal to minus 1 whole power 2 minus n dot Laplace inverse of f of s. This is the formula. Although only the first one, Laplace inverse dot f dash s, it is required. It is required. So now take a tough one example. So number one, Laplace inverse of log of s minus 4 s plus 3. At first, would we take fs is equal to log of s minus 4 by s plus 3. What would we do? So fs is equal to, we can write that log of s minus 4 minus log of s plus 3. So f dash of s is equal to 1 by s minus 4 by 1 by s plus 3. So Laplace inverse of f dash s, or Laplace inverse of 1 by s minus 4 minus Laplace inverse of 1 by s minus 3, it would be like e power 40, it is plus 1, e power minus 40 minus e power 3t. And we know Laplace inverse dot f dash s, it is equal to Laplace inverse of f dash s, and it is equal to minus t dot Laplace inverse of f of s. So f of s, so it is e power 40 minus e power minus 3t. It is minus t dot ft. It is ft. So ft would be e power 40 minus e power 3t by minus t. It's done now. I am explaining it again, and as the video gets longer, so I am cutting it now. Laplace of inverse of log of s minus 4 by s plus 3. So so at first we take f is equal to log of s minus 4 by s plus 3. So fs is equal to, by log formula, log a by log b is equal to log a minus log b. So by that formula, log of s minus 4 minus log of s plus 3, f dash s is 1 by s minus 4 minus 1 by s plus 3. Laplace inverse of f dash s, this Laplace, or Laplace inverse of 1 by s minus 4 minus Laplace inverse of 1 by s plus 3, it is for this e power 40 and for the e power minus 3t. And we know Laplace inverse of f dash s is equal to minus t, Laplace inverse of fs, and this is ft. I am telling this is ft. So we got e power 40 minus minus 3t is equal to minus t dot ft, or ft would be e power 40 minus e power minus 3t by minus t. So it's done. What do we say? Like another log problem. Laplace inverse of log of s square plus b square. So here would be, we will take fs is equal to log of s square plus s square by s square plus b square. So fs is equal to again log of square plus s square minus log of s square plus b square, or f dash s is equal to 1 by s square plus s square minus 1 by s square plus b square. So Laplace inverse of f dash of s is equal to Laplace inverse of 1 by s square plus s square minus Laplace inverse of 1 by s square plus b square. So it is like 1 by a sin at minus 1 by b sin bt. Laplace inverse of f dash s, we know it is minus t ft. So ft would be 1 by minus t dot 1 by a sin at minus 1 by b sin bt. If we take minus t into that, so 1 by t into sin bt by b minus sin at by a. This is done. So what if we take another one tough problem, like some complex ones? Let's check. If you in any mathematical Olympiad or somewhere, you go and that is like this type of integral, e power minus st No, I'm leave it. Laplace of e power 5t dot t cos 2t. What would you do now? What would you do now? So, at first solve for Laplace of t cos 2t. We know that Laplace of e power at ft is equal to f of t minus a. You know that it is f of t minus a. So at first for Laplace of t cos 2t. Laplace of t cos 2t. What would be Laplace of t cos 2t? So it will be minus d by ds of Laplace of cos 2t is equal to as by s square plus 4. So it will be minus of s square plus 4 whole square, s square plus 4 into 1 minus s into 2s. So it is equal to 2s square minus s square minus 4 by s square plus 4 whole square. It is equal to s square minus 4 by s square plus 4 the whole square. So now Laplace of e power 5t dot t dot cos 2t. So it will be like f of t minus a. This is ft, and Laplace of e power atft is equal to f of t minus a. Ft is equal to ft is fs is equal to Laplace of ft is fs is equal to here. So now we would do f of t minus a. So here we would put s minus 5 whole square minus 4, s minus 5 whole square plus 4 whole square. It's done. We understand it is pretty a good one, tough one. If you would go in mathematical computation, you are seeing like this one problem 0 to infinity e power minus st e power 5t dot t cos 2t dt. You would say, humble by how much tough this is one. But if we do by this, so at first when Laplace of e power 5t t cos 2t is here, so we know that Laplace of e power atft is equal to f of t minus a. E power f of t minus a. So for Laplace of t cos 2t, Laplace of t cos 2t is we know Laplace of t ft is equal to minus d by ds of fs. Fs is equal to Laplace of ft, Laplace of cos 2t. Laplace of cos 2t is s by s square plus s by s square plus 4. It is minus of s square plus 4 into 1 minus s dot 2s. 2s came from where? Differentiation of s square plus 4. So now we would minus, multiplying the minus inside. 2 s square minus s square minus 4. It's s square minus 4 minus s square plus 4 whole square. Laplace of e power atft is equal to f of t minus f of s minus a. So s minus 5. This is s. This is understand it. This is s. S minus 5 whole square minus 4 by s minus 5 the whole square plus 4 the whole square. That's right. So yesterday and tomorrow the lecture 3. Lecture 3. There will be proof of third formula. Some more questions. And fourth formula will be done. So this is for today. Okay.